Hi, and welcome to the next video in the series to learn more about the atomic structure. So in the last video, we looked at molecules, atoms, and why we sort of work at the level of atoms and trying to explain phenomena we see around us. So now, if you remember, in the last video, we drew an atom to look something like that. So it had a very dense center, which was called the nucleus, and a region around it, which is predominantly empty space, which has certain particles called electrons. We also looked at what a particle is. Particle is something which can be attributed physical and chemical properties. Now, we also broke down the nucleus into protons and neutrons, two other particles, and we said that we're going to stop at this level because we don't really need to understand what this is broken down further into. But if you're interested, you can take a look at quarks, mesons, gluons, and there's a whole set of particles, which we won't look at. Now, focusing on these three particles, we have to understand one important concept. Well, it's actually a property of these particles, and that property is known as charge. So we need to understand what is charge and why we care about it. Okay, so for now, charge is a property that can be attributed to each of these three, right? And it is measured in coulombs because it was discovered by a scientist called Coulomb. And in the case of these three particles, we give it values. We assign charge in terms of an integer value. So for an electron, we say an electron has a charge of -1. A proton has a charge of +1. And a neutron has a charge of 0, which means it doesn't have a charge. Now, charge is a property by which these particles can interact with what is known as an electromagnetic field. Right. So an electromagnetic field comes from electromagnetic forces, which are one of the four fundamental forces. So you can take a look at this. I might even do a video on this later on. But for now, it's just a type of force. So me pushing something, that's a force. If I push this, I'm applying a force on it. What I'm doing is I'm applying a contact force. Gravity is also a force that's acting on this, so if I leave it, it's going to fall. That's due to a force. So forces are essentially pushes or pulls, and this is a special type of force. Now, charge is, well, if you think about electric current, you can't see it, but it does have an influence. It can interact with you. So you can get shocks, minor shocks, or even major electrocution, but it's something that you cannot see that interacts with you. So in that way, I would like to introduce an electromagnetic field in the same way you learned about gravity, where it's something that you cannot see but interacts with every object that you see around you. Electromagnetic fields are, again, a type of force which you cannot see that interacts with charged particles. So particles that possess a property, right? And current is nothing but the flow of charged particles. And in that case, it's usually the flow of electrons. Now, since we have assigned charges to these, we need to talk about how they interact. So, an interesting property about charges is that they're not always attractive, and they're not always an attractive force like gravity. They can also repel. So, like charges, repel, unlike charges, attract. So this means that if you have two particles that have the same charge, like the negative signs over here, they repel. Or if both of them are positive, they repel. However, if you have a charge that's positive and another particle that's negative, then they will attract each other, just like how gravity pulls us to the Earth. In the same way, these particles will pull each other towards a center. Now, the reason we're interested in this is because this was the foundation of understanding how an atom works. So an atom, let's draw a big one here, has a positively charged nucleus, and negatively charged electrons. And we know that if this one's positive and this one's negative, they are going to attract each other. In the same way the sun pulls the earth, and the earth pulls the sun. So this was the essence for the development of various atomic models. Now, the first atomic model that came was Rutherford model. The first relevant one that we're going to look at. There were a few before this, such as J.J. Thomson, but this is a more interesting one to look at. And he proposed the planetary model, which basically states that electrons revolve around the nucleus in the same way that the planets revolve around the sun. The only difference, however, is that in the case of the atom, the forces are electrostatic in nature, and in the case of the planets, the forces are gravitational. So you have two different types of forces, but the interactions are very similar in that this one is also attractive and gravitational is also attractive. Now, Rutherford's model made sense, but there is one thing that he didn't account for. There is a fundamental difference between electrostatic forces and gravitational forces, and this soon became a problem for Rutherford. So if you have a charged particle, like an electron for example, and if you accelerate the particle, what will happen is that it will start releasing energy. And this energy is in the form of electromagnetic radiation. So any charged particle, a particle that possesses this property, if it accelerates, starts moving faster and faster, it's going to start emitting energy. And if it does so, it's going to eventually start slowing down, right? So if this is going faster and it loses some energy, it's going to slow down. And if that happens, then the electrons are going to start spiraling inwards into the nucleus. Now the consequence of that is that the atoms won't be stable, right? Because it's slowly falling apart. And if atoms are unstable, then matter itself cannot exist. So this pen cannot exist. Now, this assumption is based on the fact that electrons accelerate when they revolve around the nucleus. And if you want to look at this further, you could probably look up centripetal acceleration. It's identical in the case of planets as well. When they revolve around the sun, they are in fact accelerating even if they have the same speed. And that is because the direction in which they're moving changes, because it's a circle. But I'm not going to delve too much into that, and I might make a video on that later on. Now, to solve all of these problems, there was a new atomic model that was proposed by Niels Bohr, and although it's not entirely accurate, it does explain a lot of physical phenomena that we see around us and can be used to even calculate some values. And so, in the next video, we're going to look at this very important model that's still being used and taught, and this is Bohr's atomic model.